Hello, good day, ladies and gentlemen. Welcome to this webinar. Great opportunity. It's a collaboration webinar between StruSoft and IDEA StatiCa, two software companies, and we have a special guest today from Ramboll Design Office. And we will talk about the BIM link and cooperation between the application of FEM-Design and IDEA StatiCa Checkbot and Connection. So it will be all about steel structures and steel connections. So let's introduce ourselves. My pleasure to have Claus Jensen here, structure engineer from Ramboll. Claus, how are you today?
Good, Adam. Thanks for. I'm here. Thanks for having us.
That's great. Okay, and next to this, there is Akos Rektoris, structure engineer as well, but on the side of a software producer from StruSoft. Akos, how about you?
Fine, thanks. I'm ready.
Okay, that's great. Right. We are all ready. And for myself, my name is Adam. I'm from IDEA StatiCa and also former structure engineer. So that's a great engineering group, what to say. So let me continue with the agenda today. We will have about 60 minutes for this webinar, and we will first introduce what we do, both software companies. Then we will hand over to show you the workflow overview. How does it work, the cooperation between these two softwares. Then we'll show you live demos on how to handle some situations, how to do the job. And then we will hand over the presenter to Claus, who will tell us his experience from the daily job as a structure engineer using these two softwares and his insights and remarks. And then we will close the webinar, and thank you for you being here with us today. So that's it. And for me, let's start with my part of the presentation, introducing IDEA StatiCa. As I said, I work for IDEA StatiCa for 6 years as a product engineer. So my job is to provide all the technical support, all the preparation of webinars, meeting you at conferences. We talk to our developers what to improve and so on. So just a little about this, and let's talk about what we do. So IDEA StatiCa, few of you know probably, we are a software producer located in Czech Republic, and what we do is that we provide the world-leading solution for design of structure details such as steel connections, concrete details, and critical members. There are some numbers below that we are present pretty much all over the world. We have now more than 6,000 customers and are linked to pretty much a couple of softwares with our BIM links. FEM-Design being one of them, of course, something to be proud of. And how we started about 30 years ago. That was the core team, started with programming, structural designing software, and that's what we stick to up to now. IDEA StatiCa as a software package. Let's see where it is as a tool in the world of engineering software or structure engineering software. What we focus on is the structure details. So we focus on steel connections, discontinuity regions in concrete structures, and so on. And we don't deal with the global structure model. This is where FEM-Design shines. So we actually cooperate with this and other producers. So this is where we fit ourselves into this world to be a global leader in providing structural details software or solution. As for the perspective of engineering or engineer's toolkit, a typical structural engineer would have the global structural analysis software such as FEM-Design, then perhaps some CAD solutions such as Tekla or Revit, and then what he needs as well is something for do the code checks of details, and this is where IDEA StatiCa is for. So this would be the ideal toolkit of a structural engineer. And why are we so successful with our software? It's thanks to this patent that we have and something that we developed and that we are proud of, and what we called component-based finite element model, in shortcut CBFEM. And this is basically a combination of a component model, very well and very well known and very used approach how to model and analyze and code check steel connections. But this, let's say, technology or approach has quite some limitations, mainly in the geometry, topology, in the types of designs you can code check with this approach. And this is why we incorporated finite elements, and together these two methods provide an ultimate solution where you have almost absolute freedom in what you can model and what you can code check and analyze. So this is incorporated in our applications. And what is our mission? So IDEA StatiCa is here in this world to be and stay as a primary product or producer for structural engineers to do the code checks and to provide software that is fully integrated into the workflows with your FEA and CAD application softwares. And we want to become the most comfortable and the best solution for this job. All right, that's for the introduction of the company I work for, and I will now switch presenter to Akos, and he will continue with his part about StruSoft.
Thank you, Adam. My name is Akos Rektoris. I'm a product manager at StruSoft and responsible for the interoperability development of FEM-Design. I'm a structural engineer by profession, and I have been working for more than 20 years in the development and improvement of BIM-based collaboration between design disciplines. 20 years at Graphisoft and 11 years at StruSoft. I'm one of the founders and evangelists of the Open BIM movement and one of the shapers of the IFC and SCF standards in theory and in practice. Allow me to briefly introduce our company, StruSoft, where I have more than 240 colleagues in 19 international offices, mainly in Europe. We are developing several design software for structural engineers, and now you can see the most well-known ones. Among them, the most popular and successful software is FEM-Design, which we develop in Hungary, Budapest. We have more than 10,000 users and are proud to be the market leader in Scandinavia. FEM-Design is an analysis software for linear and nonlinear tasks, statics and dynamics. With the exception of aluminum, you can design structures of all materials, for example, cast in situ and precast concrete, steel, composite, timber, cross-laminated timber structures, masonry, and foundations. We are ready to work with any architectural or structural software available in our markets. We are Open BIM fanatics and supporters, so FEM-Design supports many open standard-based and direct connection. Among them, today's webinar describes in detail the intelligent connection between FEM-Design and IDEA StatiCa, released in February. This connection allows us to sending 3D steel structures or even just selected connected members modeled and designed in FEM-Design as intelligent input for detailed design, verification, and optimization of steer connections with IDEA StatiCa. First, let's give a brief overview of the work process and steps of this connection. The starting model of the steer structure or mixed structure itself can come from any BIM modeling software, thanks to IFC, SCF, or direct connections, or from parametric modelers, for example, Grasshopper, Dynamo, or from external programming or database. Or they can be created with FEM-Design's modeling tool from scratch or based on CAD drawings. I would like to show the workflow steps and features. Later in live, but let's go through the steps. So we can then build the final analytical model by completing it with the supports, the element connections, and with a 3D soil model if required by the given task. When we create the loads manually or automatically, such as the self-weight or the wind or the snow acting on the building cover, or called the building envelopes, or the deviation, the seismic, and the dynamic loads, then we can assign these loads to load groups, from which load combinations can be automatically generated. We can then run the analysis calculations and check the utilization of the steer bars for the given design data, their cross-sections, and materials. Or we can optimize the dimensions and materials for each limit state according to Eurocode regulations. In addition to the steer design results, we also get the internal forces, of course, for the bars from the selected load combinations from both linear and nonlinear calculation. These forces can be shared with IDEA StatiCa to design the bar connections. Finally, we need to determine which bar connections joints we want to share with IDEA StatiCa for detailed design and documentation. The transfer of the data is done between FEM-Design and IDEA StatiCa Checkbot, and in two possible ways: via a live direct connection if both programs are available on the computer, or via a dedicated file if the two programs run on separate computers. In the case of a live connection in FEM-Design, we can select which installed IDEA StatiCa version we want to work with and enter the name of the project. The connection works with IDEA StatiCa 22 and the new 23. In the case of file sharing, we use an open source Excel-based format, the so-called SCF, or structure analysis format, intended for storing and sharing analytical models. Thanks to its Excel nature, its structure and content are easy to understand. During both connections, the following data are transferred: the selected nodes, joints, the bars connected to the nodes, and the characteristics of the bars, so their position, including eccentricity, geometry, cross-sections, and material. And, of course, the internal forces calculated from the load cases and or selected load combinations. The matching between the cross-section and the material basis of the two software is done automatically on the FEM-Design side via an Excel file that we can easily edit. If there are unmatched FEM-Design cross-sections, they are exported with a parametric description based on which IDEA StatiCa creates the same cross-sections. In both connection modes, it is possible to decide whether to transfer the entire analytical model or only the selected connections and their members. And then the steer connections loaded and displayed in Checkbot can be designed in the usual way, which means selected nodes can be opened, examined, detailed, and documented with IDEA StatiCa Connection based on connection templates and configurations, as well as the optimization of fabrication and raw material costs. Of course, it is possible to design not only the connections between bars, but also the bar end connections at the supports. Let me talk about the data synchronization. In case of the live connection, a single click updates the input of the IDEA StatiCa connection design based on changes in the linked FEM-Design model. So if we change the loads, the material qualities, or the cross-sections in the FEM-Design model, here in the picture, the I-shape profile of a column to a closed section, and we rerun the analysis, then by clicking a sync button in Checkbot, the model and the calculation results, the internal forces will be updated in the IDEA StatiCa project too. Now let's see the connection workflow live in practice. I show you FEM-Design. I got this project from a client. He created the analytical model based on a BIM model. And yes, I would like to show you the steps how we can build up a model ready for the IDEA StatiCa connection. When the analytical model members are created from the BIM model, or you can use the BIM tools of FEM-Design, so you can create beams, columns, plates, and so on. You can extend the model, for example, with foundation, and also the 3D model of the soil. You can define it with different ground layers, strata, and groundwater level. Then we can define the foundations, as mentioned, the supports, and if needed, for example, connections between the elements. We can apply also surface distributed loads on beams and wind braces thanks to the cover objects. Using them, FEM-Design automatically distributes surface loads assigned to them to bars. Then I could go to the loads, and as you see, the client created different loads. The program automatically calculates the self-weight, of course. You can define a live load manually, for example, or you can create climate loads, such as snow load and wind components, based on wizards and using the coverings as a climate panel objects. Then when we are ready, yes, of course, the simple loads can be extended with temperature loads, stress loads, support motions, dynamic loads, including, for example, the seismic loads, or moving loads or deviation. The loads are stored in load cases. Then you can assign them to load groups. And if I select, for example, one load group here, you can see that based on the safety factor and the relationship, it's alternative or simultaneous, the program can automatically generate all the necessary load combinations, as you see here. And yes, we are ready with the load combinations. And then, although FEM-Design is a finite element analysis software, the finite element mesh itself is created automatically and with element size optimized for the object sizes, shapes, and connections. Of course, if you want, you can manually control and build up the recommended finite element mesh. And here you see that with the help of FEM-Design, we can perform different design depending on the structural materials. Now in this presentation, we focus on steel design. The minimum calculation requirement for the IDEA StatiCa connection is to run an analysis and for load combinations. So I pick load combinations, and we can select here in the next table for which load combinations we want to design, and so of which combination we want to share the internal forces with IDEA StatiCa. I select only 2 combinations, and here you see that I can also consider the nonlinear behavior of the structure elements, such as uplifting and so on. As an important feature, yes, I highlighted that we can also run nonlinear calculation, and we can share these results with IDEA StatiCa. We may also run steer design or steer check. There are 2 options. We can check all structural elements based on their utilization and check that they are suitable for the standard requirements. Or we can run automatic design that optimize the profile and the material of the steer bars based on the utilization. Now I start the calculation. In case of linear calculations, only IDEA StatiCa will combine the result of load cases based on the safety factors. But now I check nonlinearity also. And here you see that the program warns us that stability test also recommended for slender vine braces. But I can skip it if I don't mind it. Here you see that the analysis algorithm, calculation algorithm is very, very fast, even for nonlinear calculations. In the last step, we have to define which bar connections or nodes we want to design with IDEA StatiCa. So I can go to plan view, for example, and I select these 2 frame parts. How just start define joints, and there is a special command to do that. We can use this generate joint command and just select these elements. And then if I go to 3D view and I hide the physical bodies, you see the connections I would like to share with IDEA StatiCa. And that's all. Now the model is ready for sharing. And as I already mentioned, I can use 2 ways to share the model. There is a so-called live connection or direct connection if both programs are available on the computer, or I can use a dedicated file, SCF, in the background if 2 programs run on separate computers. Now I would like to show you the live connection. But before I start the file sharing, I think it's worth to speak about how we can manage the data pairing between the 2 software. So as I mentioned before, the data pairing is done on the FEM-Design side. We can use an Excel file for that. And here you can see in the column E that we can pair, for example, here you see the stair materials, here you see all the profiles match between the 2 databases. If you have a new material or a new profile which is not available in the database of the StruSoft software, you can define them in the 2 softwares, and also you should extend this table with this new data. And as I mentioned before, unmatched FEM-Design cross-sections are exported with parametric description based on which IDEA StatiCa creates the sections. Now I go back to FEM-Design and start the live connection. Just click on IDEA StatiCa Checkbot command, select the nodes I created. And here you see that I can select which version I would like to work with in IDEA StatiCa. The connection detects what version is installed on my computer. Now I use the latest version. And I can give a name for the IDEA StatiCa project. For example, I use today. Then I press OK, and this OK drives the opens IDEA StatiCa Checkbot, and it also show the name what I created. So you are not able to modify the name. So this is the project name today. I typed before. You can choose a design code if you want, and with a single click on create project, we are here, and with connections, we import all data exported from FEM-Design. Here you are. So it exports the connections I selected. As you see, here are the profiles. You can check them under materials. So these are the profiles coming from FEM-Design and recognized by IDEA StatiCa. And here you see the material. And of course, you can also see the internal forces, for example, the MY diagram. I show it in wireframe mode, and I scale the result. Then I put it here, and on the other part I put FEM-Design, and I show you the results. I forgot to show you the utilization, so these are the steel utilization results of the bars, but here you see also the internal forces, for example, the same diagram what you see in IDEA StatiCa. So for example, here you see the node 21, here you see the node 21, and the moment value is the same on both sides. And I would like to show you the live update. So if I go back to FEM-Design, and for example, I change, first I hide the colors, I show you only the steel structure. So if I select, for example, a column and modify the cross-section of this from I-shape to a closed one, I search for that here, I check this one, and I also modify, for example, the loads. For example, the snow loads you see here, with one click, I select all loads, and maybe I double it. And what I need is to restart analysis, go to load combinations, press OK. Now the software do again the linear and non-linear calculations of the whole structure, of course. And when it is ready, here you see the steps that it calculates the internal forces for the combinations, the non-linear, such as uplifting, check it if it's available or not. And then I go back to IDEA StatiCa and just click synchronize. And it synchronizes all data. So if there are new profiles, materials, if there are new results, and if you see the moment, it modified. And also, if I turn on the solid representation of the elements, you see that there is the closed session, the same section what we have in FEM-Design, but you can also check it under materials. Now I give the word to Adam to continue the detailing, how he can detail the connections in IDEA StatiCa. Thank you.
Yes, so now I'm back, and you should see my desktop with IDEA StatiCa opened, and here I will just open the standalone Checkbot application. It can be opened on your computer, and I will now, let's say, simulate the case where Akos is my colleague from different department. He dealt with the global steel structure. He designed it, analyzed it, and now I am his colleague from steel detailing department, and my part is to design and code check steel connections. So he sent me this, sorry, it's open here, this file. That's the second option. As he demonstrated, he generated this XML file, the CEF file, and I will now use it to open the data and continue with the work. So with the Checkbot open, I will use the same same name as Akos. So let's call it today the project. And with Checkbot, I can choose whether I'm dealing with steel or concrete project type, and I can also choose one of the 8 national codes that we have incorporated in our software. So let's stick to Eurocode and create the project. This means I have a blank Checkbot application here, and I will call the SAF import and navigate to this file I showed you, and this imports me the data. Now this import takes half a minute, so to skip this, I have it already opened in another window. So let's continue with this one and not wait half a minute when the data are being processed. So this is the same steel hall as Akos showed you, the customer project. If I hide the labels of the members so we have better visibility, this is the 2 frames that Akos imported as with direct link into Checkbot, and I can now continue the job. So a very brief introduction to Checkbot. What we have here, the import functions, few commands to show and hide labels for members connections. These commands serve to open, delete, reset the imported nodes, which are represented by these cubes, and which list is on the right side of the tree menu here. So for example, if I select this footing node, it's highlighted in the tree window, and I can work with it with these commands or by right click. What I can do on the right click as well is to save this one only or multiple nodes like this into IDEA StatiCa connection file and send it even to somebody else, only the connection files without the Checkbot project. So this is also possible. Then what we have here, and this is important, the loads manager. What I have here, the data imported from the FEM-Design, there are in this case 2 load combinations or load cases, and this is what is imported on the left side, and in the middle I've got created one result class or one folder including these 2. So this is what's used for the analysis and code check in IDEA StatiCa, and I can of course modify this by deleting one or deleting the whole folder, creating one. So this is, let's say, the load manager. Yeah, and here there is one thing I want to mention. This tick box turns on or off a special feature to evaluate critical effects. In other words, if this is on and you have a lot of combinations, maybe 50 of them, it will filter out and neglect those that are not dangerous, that has less effects than the ones that will be used. So this is some kind of automatic algorithm to filter out the combinations or load effects that are not dangerous and that will just slow down the analysis and don't have to be used. Of course, you can control all of this, depends on you. So that's the load configurator. Then some settings to set the costs, pre-design function, far design function, and so on. I will not go deeper into this. Then, of course, you can draw the internal forces. So if I select this one, I can choose if I want the load case or the whole folder, show me all the effects, and click on one node. I've got the diagram of, in this case, MY moment drawn. Yeah, so it works like this. If I go back to solid view and scaling and choosing if I want to load local extreme and so on. And these functions are here if, for example, you delete the node or you miss it from the data, you can add a node and build a connection based on the data of the members around it. So this is in the case you are missing something in the imported data, you can replace it. All right, so what do I do next is I will start with the connection design. So I will pick one of the connections. For me, the most interesting here is this connection because it's a frame connection with wind bracings as well. So that's, let's say, a challenging one to play with. So I select it and click open. And oops, what happens is, sorry, I have a mismatch of my monitors, my screens. Now it's here. So I have to drag the correct one. Okay, so I've opened this connection. As you can see, that's the frame, the wind bracings, and the continuous beams on sides. And now my task is to design this connection and code check it. So let's do that. This is the IDEA StatiCa Connection application, and I can start with the first phase, and that's the modeling or creating the design. As you can see, the geometry, that means all the members and its cross sections, is imported, as well as the load cases or load combinations. I can check here. I can see the numbers or the values of the internal forces. I can also check the unbalanced forces. This should be 0 or very close to 0. This means we have equilibrium in the node, which is the basic law of statics, of course. So here I have a visual control if everything is all right. I didn't do any mistake or typo, or there is something wrong with the data maybe. So this is always good to take a look at. All right, and now let's start with the design. So to do or to create a design, we have few options. We can start with the adding operations. This is the list of operations that we have in IDEA StatiCa Connection. The first 3 rows produces, let's say, complex operations. That means this produces, for example, an end plate. That means the plate, the bolt, the welds, cuts of the members that are connected, everything at once, and I just modify parameters of the operation. So if I click on this and choose maybe the default bolt group for this, I can see there is some operation created, and I just change the members, and by choosing or modifying these parameters, I end up with the design I want to create. But I will delete this one for, in this case, I show you another option. Another option is by right click saying connect me this member to this member. This shows you the connection library. This is a proposed function and shows you some possible, let's say, templates suitable for such a connection. And the third option is to open the connection library as a whole and try to find a design that is suitable for the whole joint for the whole node with all the members all together, not one by one, not by adding manually the operations one by one, but doing this as a whole. I can see for this design, this configuration of geometry, this column beam, which is tilted, 2 side members and these 2 wind bracings, I have no design here. I can try in this case to select only the members without the wind bracings, which is still somehow more often design. So I clicked by holding Control on my keyboard, selected all the members, confirmed by spacebar or clicking on this icon, and I can see the connection library found me one suitable design for this combination of members and their vectors. So I can apply this one, confirm which bolts should be used for all the connections, and confirm this. So I can see now by using this connection library, there are 6 operations now added, and I can see part of the connection is designed in one click. And I can just review the operations and what is in the model now. So there is cut operation that aligns this column with the tilted roof beam. So this shapes me the frame corner. I've got the end plate, which connects the frame member with the column, produces the welds of size of 5 millimeters, produces the bolts. In this case, I would like to use slightly bigger bolts, M24, so I just modify it like this, and I can see immediately in this 3D scene that about the change. So I've got full control. Of course, I can do any other modification anytime, no problem with that. But I'm fine with this. Let me check what more I have here. This is the widener operation that produces me this haunch, which is also cut and welded. And what else is here? The stiffener on top of the column, welded on both sides. That's fine. And then we've got 2 fin plates to connect the side beams here. Okay. 1 and 2. So what I'm missing here is to connect the wind bracings. So for this, I will use the manual operations. And here I will choose the connecting plate operation, something typical for connecting wind bracing. So I added this new operation. It tells me there is something wrong. This is just information for me that I need to select the correct member. So I click on this little arrow and select the wind bracing, and I already see some plate generated. So let me modify this even more. So this is related to or connected to this member. If I select this correctly, you can see already that there is a plate with weld produced. Still there is something wrong. It's because I've got a wrong or not suitable type of this connecting plate. We have a couple of types here: a cup plate, double cup plate, notch member. You can use it according to what kind of cross-section you are connecting and what kind of design you would like to produce. So these are some, let's say, predefined options. So if I go here for this connection, notched plate walls, this means the wind bracing is now welded into a plate with the hole for the wind bracing. Yeah, I can switch the welds to be on both sides. This is better design for me, and now I can start shaping the connection. So what I do is to use these parameters. So the thickness of the cassette plate will be 8 millimeters. can see it gets thinner, and I will change its size to 300 by 150. Change the position of the connected plate. Change its thickness to 8 millimeters as well, and its shape as well, 110. Make it slimmer. Overlap is 100. What else? Change the thickness of the welds. I will keep the same weld thickness of 5 millimeters in this case, all over the connection. I will leave the M16 bolts and move a little bit the position of the bolt along the axis. So instead of 40, I will input 50. You can see the dimension in here. Okay, that's it. Now I would like to cut this gusset plate to have a nicer and more reasonable shape. For shaping plates, I can use via right-click editor of plates, and here I can shape the plate using these operations. Or I will ignore this option now, use a different approach, and I can add a work plane operation and use it to shape the gusset plate. So I added a work plane. I will position it as for this member T50 and move it along its axis to this place. And you see what my goal is to cut this triangle of the connecting plate. So to cut the plate, I will call another operation which is called cut of plate. And here I will choose this plate, connecting plate 1A. If I drag my mouse over any plate or part of the connection, you can see in the left bottom corner of the 3D screen the information of the name, the material, and thickness. So if I drag it to the end plate, that's a different operation, EP1 and so on. So this is the easy way how to identify which operation it, or I just click on this operation. So that's by the way to inform you. And so let's continue with cutting the plate. So I selected this plate and I will cut it by a work plane. So I need to change the parameter here, and it automatically chose the only work plane in this model, which is the work plane number 1. And you can see that the cut is already produced. Okay, this is looking better, and what I will do is I will cut it even more. So what I will take advantage of one existing work plane, make a copy of this operation, and only change its values. So instead of moving it along its axis, I will move it a little bit down and rotate it by 90 degrees and have it right like this. And you can see probably already my goal that I will use another P-cut operation and just choose the different plane and revert this cut to cut this off and leave this here in the model. And this way I have shaped this gusset plate of this connecting plate operation. Good, that's for the one. And now I move to the other connecting plate. Again, I can either add a new operation or copy the existing one, because this is much easier for me. It remembers the thicknesses and sizes, and I can just modify it. So for this one, I will change the member from T50 to this T11 and modify the parameters to fit the design. So thickness is the same, the size will be slightly different. I made it a shorter plate here, and I will also shift the connection towards the node. and I will change the size of the connecting plate. 70 is fine, and 50 here. So here it will be smaller. And that's it for the connection. And what I will do now is I cut this plate and weld it to the web of the column to have a, let's say, this welded by two sides. So I will create another cut-off plate operation. Select this plate, select this member, say I want a cut by surface of the member that will identify where the plate touches the web of the column, and cut the plate. If I switch to transparent view to see, for you to see, as well as produce the weld. The weld will be 5 millimeters and on both sides. Okay, the last thing here is to use another work plane to cut this this triangle out. So again, I will create a work plane operation, select member T11 and input the distance that I want to cut out the plate, and use the pcut operation. So this plate by the last work plane operation and revert which part is cut out. Okay, so this way I'm done, I'm finished with the design, and the last thing is that I will change the model type. These diagonals, they cannot take, they don't transfer any moment, and they work only in tension, compression, and shear force. So I will switch this and run the calculation. Now the finite element model is being calculated and analyzed. It calculates or analyzes all the loads and all load combinations in the model at once. So this is of course depending, or the calculation time is depending on how many load cases or combinations you are calculating and how complex the model is. So now the calculation is finished for both load cases, and I can see the results. So in short, I have a very fast overview. I've got the basic result displayed here. So all green for plates, bolts, and welds, so all code checks. Also, I have the connection model colored. Green is good. If there would be something not passing the code checks, that would be colored in a red. And if I move to the check and briefly show you the results and the code checks. So for example, if I click on this bolt, it highlights me and opens me the bolt here. I can see the basic values of tension force in the bolt and the utilization ratio in tension, shear, and combination. And if I click on this little plus button and maybe make this data bigger, visible, you can see here all the code checks as per code, as per Eurocode that is needed to perform for this bolt. This is the same for weld and for plate, and for the results I can also study the stress distribution over the connection model, as well as to display the deformed shape, so I can have also visual control of what's going on, how the connection is behaving, and I can react on this with my design, maybe stiffen something or even save some material somewhere. The last step is the report. So I generate it. I have also control what I want to have in the report, either to keep it shorter or the complex. And I can save the report in open format in doc or PDF or print out and hand it out to authority or investor or whoever ordered it. Okay, that's it for the connection design. If I save this data, close it, and go back to Checkbot, you can see now that in the list, the connection is with green mark. That means that it has been analyzed and code-checked with positive result. And I can see, if I click on that, the design of it and the basic overview of the code checks. And this way I can continue with the other connections and design them one by one to get the job done. And that was it for my part for the demo. And I'm handing over presenter to Claus now to hear about his experience.
Yeah, thanks, Adam. I guess you can all hear me and see my screen now. So
Yes.
I'll just start explaining a bit about myself. As Akash and Adam said, I'm a structural engineer as well. And I just put in a few bullet points of kind of my interests. So finite element analysis, steel structures, automation, and what I call structural sustainability. I currently work in Ramboll, Denmark, in the department of buildings, large projects, where we are sitting 35 structural engineers and technicians. And previously, I've worked in Europe and worked both in Berlin and Copenhagen. And a little bit about Ramboll. We are an independent architecture, engineering, and consultancy company owned by the Ramboll Foundation, founded in 1945, and currently there are 17,500 employees present in 35 countries. So I figured it was a bit overwhelming to start speaking about global projects and all that stuff. So I picked out a few projects that are located in Copenhagen and that my department has actually helped on. The first one being the Opera House in Copenhagen, second one being the Mast Tower, and the third one being the Bella Sky Hotel, which we can actually see here from the head office in Copenhagen. I wanted to start off with just explaining how we in Ramboll use FEM-Design today, and then afterwards how we use IDEA StatiCa. If we start off with FEM-Design, you'll see situations where we just model 1D members, do the design check, move on, or 2D frames, whatever. But we'll also use it for larger models where we extract the analysis results and use that in various types of verifications, etc. And finally, of course, we'll also have these big models where kind of using the true power of FEM-Design and doing the design within the software itself. The StatiCa bullet points here are a bit more of a timeline. So we started with kind of designing very complex existing connections that might need it strengthening. Then we moved on to more complex connection design that are harder to solve by hand. And now what we're seeing is that this has transformed into a scenario where we are doing generally many verifications of connections during the detailed design stage. And although this is not part of the webinar, I just want to highlight that in this transition of using big models, a lot of designer connections is of course even more important that we engineers pay attention to what we actually put into these softwares. So when I found out about the connection between FEM-Design and IDEA StatiCa, I got very excited. And I also had some thoughts that how I was expected this connection to work. And these were my thoughts. I've split it into 4 elements. See a lot of potential in the fact that the software will automatically handle forces and geometry of members. So currently there are several ways to carry over information, but normally it requires some kind of manual effort. And that could, of course, lead to mistakes in the what I put in load magnitude, sign convention, what did we actually use, the critical load combinations, are we using the right section sizes, member angles correct, etc., etc. The link should ensure that this will not happen. Most importantly, there's a big potential for time saving for us as engineers. Maintaining models updates is not fun and it's not fast, and the link should be able to help us out with that. And then finally, I just mentioned the potential of the optimization. So what we see is that we kind of, when we do connection design, we often do very large groups of connections, and we design them to an envelope design, so it's fast and it's always a conservative design. And by having this with attention, of course, there's a potential to kind of optimize the way we work. So just a few pictures that what we've learned so far. And as both Akash and Adam has already showed, the live force diagrams it's something that we didn't know we needed, but it's really, really important. And the way that we can compare the two models, we can ensure that the connection is doing what we want it to, is extremely important. And then in the other picture over here, I put in kind of the syncing model symbol that you also quickly saw. And it's to highlight how important it is that you consider what data you transfer, how much data you transfer between the two. Otherwise, you end up with this syncing model for a long time. Also, did you remember to run your model? Did you remember to press analyze in FEM-Design? And have you saved your model before starting the synchronization? And then here I have a few videos, and it's just highlighting how cool I think the live updates is working through the Checkbot. So the first one on the left that we're seeing now, we're changing the geometry of the beam and we're changing the loads. And just within a few seconds, I think, yeah, we changed it from a HEB 400 to a HEB 700, and we also made a load update to the live load from 5 kPa to 10 kPa. And while running the model, you'll kind of notice that the forces have updated accordingly, and as well as the members. So we'll see that right here, and it goes pretty fast, as you can see. So now the right video starts. We have the HEB 400 again, exactly the same model, and I quickly go back into my FEM-Design. And then I do the exact same change that we just had in the other example, but I want to go into more detail about the actual joint that Adam was showing. So if we pay attention to how we define our joints in FEM-Design and how we do our operations, you saw that Adam had a lot of various options to do operations that actually does the same thing, and in order to save time. But if you actually think about how you do it, you can kind of set up a parametrically defined joint that even if you change your member, the connection will follow with it. So you saw in the picture before that I had some stiffeners, I had an end plate that were all defined together with the member, and I also had my bolts position defined. And in this example here, which should show in the second, you'll see how the stiffeners and the end plate and the bolts are all following with it. The design might not work, but at least we don't have to deal with any errors or in the connection design because we've changed the member types. So let's just wait a second for that to come up. So you see that here we have the stiffness moving with the flanges of the beam, and we keep our bolt positions defined by the flanges. So finally, I just quickly wanted to go through some of the next steps that I think we need to work on together. First one being how we make the tool even better, how we make more people want to use it. And with any other digital tool, stability, robustness, and speed is key. So the faster we can make it, the more people will start using it. And then I think what we've noticed here is that once you get started with the software, I'm sure people who are in this webinar who's used the software end up with some typical problems while using the connection. That could be forgetting to running the model, for example. And I suggest that we kind of set up some some tutorials or something like that, where what to do in this situation when this doesn't work. Secondly, I put in some about the future studies. So we need to, as engineers, we need to dare to use it. We need to just keep using it. The more we use it, the better it becomes, the more comfortable we feel with it. Personally, I like having case studies when I do my FEM-Design model, when I do my IDEA StatiCa connection. It's nice to have some simple connections, moment frames, something like that, and then also you can test it out in the connections, and you can have something that you feel comfortable with. And if you're comfortable with that workflow, it's easier to feel comfortable with more complex connections, etc. And then I put in automation because, of course, in my head, this shouts to set up a workflow which utilizes the FEM-Design API. And we haven't got there yet, but I would suggest anyone who's up for it to start looking at it. And then secondly, of course, although mentioning the optimization studies, it's nice to be able to bundle connections, have the same group, and then check for the same load combination still, at least, to not have to do all connections one by one. And then I put in projects because finally the most important thing is, of course, how this becomes relevant on projects. And before we start up using it, we should consider to what extent you see the benefits of using it is. And I think there's a lot of benefits, but it's nice to consider it before you start. How can we provide a better and faster solution? And just finally, when we start using it really on projects and it gets used by more and more people, the only way we can make an even better connection is to feedback to both StruSoft and IDEA from real projects, basically. So yeah, that's it for me, and I'll just hand it back to Akash.
Thank you, Klaus, for your presentation and your suggestions and the useful feedback. We ran out the time, but please let me give a brief summary of the key
Sorry, Akash, I think we lost your audio.
Sorry, I'm here.
Yes, you are back.
Thank you, Adam. So let me give you a short, brief summary, although we are run out of the design time. So thanks to the connection, the model created and the calculation performed in FEM-Design provide valuable input for IDEA StatiCa tasks. In addition to the steerbar geometries and properties, the bar internal force results calculated from the load specified in detail in FEM-Design are also transferred.
Oops, looks like again you.
Sorry.
Yes, you're back.
I muted again. So the data association between the two software is done automatically, but under the control of the users. In addition to the entire structure, especially if it's a large or very complex model, only selected connections and the data can be transferred to Checkbot. Data transfer is quick and easy with the dedicated direct, so-called live connection, or thanks to the easy to understand small-sized but detailed SAF files. In case of the live connection, a single click synchronizes the changes in the FEM-Design model in the IDEA StatiCa project. And finally, no additional software installation is required to operate the connection. Everything is included in the standard installation packages of FEM-Design 22 and IDEA StatiCa. So in short, in one sentence, the common development accomplishes everything, providing a dedicated tool that accelerates the entire steel structure design and detailing workflow if FEM-Design and IDEA StatiCa are used together. A detailed description of the developed connection can be found on both the StruSoft and the IDEA StatiCa website. And those who don't yet have one of the software can try the collaboration workflow and functions introduced today with the free trial versions. The trial versions are full-featured, so you can try the other skills of the two programs without limitations. Trials can also be requested in the survey that appears after the presentation, so please fill out the survey. We are interested in your feedbacks. Of course, we are happy to answer any questions you may have or to help you with problems arising in your projects and tasks. You can send questions to our email addresses shown here, or you can also use GoToWebinar questions panel. Maybe Adam picks a few of them that are relevant to everyone. So please, Adam, tell them us, or of course we will answer the rest by mail.
Mm-hmm. Okay, maybe because we're running out of time or we are actually late. So just one question. There is a question about updating or synchronizing the model. So it's either for you, Akos, or for me. So if you change the loads in FEM-Design and update the model sent to Checkbot previously, will the update reset the connection design that I have already done, or it will stay? So maybe I can answer directly in short. No, it will not remove the design stays. It only updates the changes, so it only changes the values of internal forces or changes the cross-section of member. Mm-hmm.
Yes, you're right.
Okay, and I think we can maybe conclude this, Akos.
Yes, the webinar was recorded, so we will share the records with you. And thank you for your attention. Thank you, Adam. Thank you, Klaus.
Thank you.
Thank you very much to all our attendees, especially to Klaus, our brilliant guest. And Akos, thank you for hosting us for these webinars under your wings of StruSoft. And see you some next time. Bye-bye.
Yeah.
See you guys.
Bye-bye.
Thanks for having me. Hey.